X equals 12 over sine of 29 degrees. And I'm going to need help here. 24.8. Oliver, can you second that?
Yeah.
Okay. And that would be our final answer. That would be our missing side. Max, all the steps make sense?
Yep.
Okay, cool. Yeah.
Number 13.
Oh, either one of you. Number 13? All right, 13, we have one of those double triangles. Guys, we can't get stuck on these because you know they showed up on the quiz. They'll show up on the test as well. My goal is for you to start realizing that maybe I don't care about the double triangle. Maybe at first I just focus on a single triangle. I'm like, I can solve this triangle. But let's look what we want to solve for. Well, if I ever want to get to this triangle, I need to find this length right here. So let's call this length right here x. And now I'm thinking about, okay, if this was just this triangle, if this was just a triangle by itself, I'd go, oh, this would be opposite the 51 degrees, and this would be adjacent it, because it wouldn't be the hypotenuse. The hypotenuse has to be the one across from our 90. So we have an opposite, and we have an adjacent. There's only one trig that doesn't use the hypotenuse. What is that one? Tangent. So that should be immediately like, I have no hypotenuse, I must be using tangent. I'm going to go ahead and bring all this stuff back in and say we're going to go ahead and we're going to use tangent of, and it looks like 51 degrees, equals x over 14. Perfect. Multiply both sides by 14, and we should have 14 times tangent of 51 degrees equals x. And then we just have to plug 14 times tangent of 51 into our calculators, round it to the nearest tenth. What do we get for that? 17.3. So what you got? Okay. So that 17.3 is actually going to go right back into this problem. It is this length right here. So we're trying to find the length KL. How about I put a Y for KL? I now know a hypotenuse, and I also know, okay, this is L, so this is the hypotenuse. What would Y be for? It would be adjacent. Yep. So we would do adjacent hypotenuse. Does that sound like cosine? So adjacent over hypotenuse. Yep. So we're going to use cosine. So I'm going to go, okay, for this next triangle, let's use cosine of 72 degrees. You agreed that that Y was adjacent and that X was our hypotenuse, but that's 17.3. All you have to do now is multiply both sides by 17.3 and plug that in your calculator. Is that far enough, you think?
Yes.
Cool. Yeah. Same thing. Don't get bogged down by it being two triangles. Think about it being, I have one triangle where I know a hypotenuse, I know nothing about the other triangle. So I'm just focusing on this triangle right now. That's all I care about. And I would like to find this length here because it would hook up to the other triangle. So just picture that triangle. I'm going to bring everything back in, but just picture that one triangle. Well, this one triangle right here, I'm going to notice it has 54 degrees. X is opposite, and I have a hypotenuse. So opposite, hypotenuse, I should be using sine. So we're going to say, well, this is going to be sine of 54 degrees equals x over 20. We'd multiply both sides by 20. We'd have 20 sine of 54 degrees. When you plug that in your calculator, you're going to get this length here. Let's look what we're trying to find. We're trying to find DC. So DC right here, how about I label it as Y? So are you okay getting this? Yeah. Plugging your calculator, getting this. Now I have this length. Now I have opposite and adjacent. Well, that sounds like TOA to me. So we'd have tangent equals whatever this value is over Y. Is that far enough, or is that where you wanted to see?
Yeah, it's just, I got a different answer than the answer came out.
Oh, okay. Okay, let's go through it then. Can someone help me out? What's 20 times sine of 54?
What number again? 12?
Yep, I need 20 times sine of 54.
16.2.
Say that again?
16.2.
16.2. Can I get someone else to second at 16.2? So we're good with 16.2. We plug that in there. Now we switch to the other triangle. That other triangle, I would use tangent of 28 degrees. Would equal, TOA is opposite, so that'd be 16.2 over our adjacent, which is y. Now remember, a shortcut could be, so I multiply both sides by y, divide by tangent of 28. But ultimately, we should know that these two things switch places. It kind of speeds it up just a little bit. If I'm on a test or something, I'm looking for that edge to get me a couple extra seconds, and I have that. Did you have them flipped?
No, I put it in my calculator wrong.
Oh, okay. And then we just plug it in like that. All right, other questions? Yeah.
I don't have this piece.
Oh, yeah. And there's a review on the backside. Okay, questions going once? Going twice? So we're okay finding missing sides? Because now we're going to step it up and we're going to find a missing angle. But once again, we have to realize that this is not multiplication. It's not tangent times 28 degrees. It is tangent of 28 degrees. Just like before we start, how about we do something like this, just to get our brains going. Square root of x equals 2. How do I get x all by itself? What's the opposite of square root?
X times x.
X times close, yeah. We're on the right path. Square both sides. So you're saying take the square root of x times square root, but we're going to square both sides. You have to understand what inverses are. To get rid of something, you need to do the opposite of it. So if I'm taking the square root, I need to square both sides. It doesn't mean I divide every single time. The only reason why we divide a lot is because if I have 2x equals 4, what's the opposite of multiplication? Division. So that I would divide both sides by 2. If I had x minus 2 equals 4, what would I do to both sides? I would add, because the opposite of subtraction is adding. Just like the opposite of square root is squaring, not everything is divide both sides. You have to understand what operation's happening, and you have to undo that operation by doing its inverse. In other words, it's opposite. When you take the square root of something, if you square it, you go back to where we start from. Now, keep that in mind when we get to, not these, but these problems. You might have noticed on your calculator that you have these little inverse buttons. Usually you have to hit like a second button to get to those, and we'll go over those on the TI-84 in just a second. But you should notice if you hit sign, like right above it, they have like a sign to the negative first. That is your inverse. That is the opposite of taking the sign of something. Sine and sine inverse undo each other. That's important when we're solving for something, because let's just start this problem here. If I told you were going to do this problem yesterday, you could at least set it up. You should have at least been able to set it up, because if I look at this problem, I have sides and I have an angle. And more importantly, well, if I have two sides and a missing side, how do I usually find that missing side? If I have two, what was that, Grant? Pythagorean theorem. But are we looking for this missing side? No, we're looking for this missing angle. So be careful of what you're looking for. If you're looking for a missing angle, we have to use trig. The only special angles we know are 30, 60, 90, and 45, 45, 90, but I have to give you one of those. You have to use trig to find a missing angle. And to use trig, we're going to go back to the very first thing we learned on trig, and that is, oh, you know what? I have a side opposite, and I have a hypotenuse. Opposite or hypotenuse, does that sound like sine, cosine, or tangent? It means sine. And remember how sine works. Sine of an angle equals opposite over hypotenuse. So let's write it out. We're going to write sine of... Now, do we know the measure of this angle? No, so we're going to put an x there. We're going to say sine of some unknown angle equals opposite, which is 15, over 24.
Wait, do you reduce?
You could if you wanted to, yeah.
Doesn't matter.
It doesn't matter because we're plugging in our calculator. So my thought is, anytime I'm using trig, I have to plug in the calculator anyway. So why would I take the time to simplify it and make a mistake?
Yeah.
If you can just see it, awesome. But I'm going to plug it in a calculator, so I don't care about simplifying it. All right. Can we all look at the board real quick? Let's look right here. Here's what people that aren't going to pay attention today are going to do. They're going to go, oh, I'll just divide both things by sine. And I'll have x equals 15 over 24 over sine. That doesn't make any sense mathematically. It doesn't make any sense mathematically. In fact, this would be just like doing this. Let me go back to over here. Actually, let's go back to what I said about, let's say I have a square root of x equals 2. I said we should square both sides. You cannot divide by square root. There's no number on it. You can't divide by just square root. So in this case, you have to do the inverse, which is squaring. And it just so happens, why am I all messed up on where my slides are? There we go. It just so happens the only way to undo sine is to take the sine inverse of both sides, which is going to look like this. I'm going to take the sine inverse of sine of x, because I want x all by itself. That's going to equal the sine inverse of 15 over 24. I want to have some of that written down. Because this is all we're doing today. We're just saying, I need what's in sine or cosine or tangent, and I need to get x out of there. The way you're going to do that is you're going to take the inverse of both sides. Now, what the inverse does is it cancels out the sine. So sine inverse and sine actually just cancel out. They just get rid of each other. It's like if you have 2 times 1/2, you're left with 1. Multiplication, division undo each other. Subtraction and addition undo each other. Inverse and sine undo each other. That's going to leave me with x equals sine inverse of 15 over 24. Now, you should not know what that is. And it says round to the nearest tenth, which means you need to use your calculator. So let me bring up my calculator really quick to show you on a T84. Make sure we're in degree mode. Everyone should be in degree mode. You should not have changed that on your own. And we are typing in sine inverse. Now, for all of yours, you pretty much have to find like some second button. It might have just a color. It depends on what your calculator is. For the TI-84, it's right here. If you hit that big blue button, it's going to do a little arrow. Now find sine, and notice how blue matches up with sine inverse. So I'm going to hit the sine button, and instead of it displaying sine, it's going to display sine inverse. And then we just have to type in, what fraction am I typing in? What was that?
15 over 24.
15 over 24? I got 38.7. 38.7 would be correct. 38.7 would be our correct answer. So I'm going to come back here and I'm going to say, you know what? X is about 38.7. And I should probably put degree symbol up there because I'm finding a missing angle. Yeah.
You like count off on the test if we don't do like the squiggly?
No.
Equal?
No.
Okay.
I'm also going to note you don't have to do all of these steps. You can't. I strongly encourage it, especially when you're first starting out, understanding how this all works. But we can look over here and say, oh, you know what? Sine of x equals opposite over hypotenuse. Sine inverse of opposite over hypotenuse equals x. So if at any point I'm missing an angle, you anytime you're missing an angle, you better understand that you are using an inverse. So missing angle means you need to end up using an inverse. So if I just look at this next problem, I'm missing an angle, which means I have to use some sort of inverse. Let's go ahead and go through number 2. Number 2, let's pretend I didn't know it was inverse. Let's just say I have an angle in 2 sides, which means I'm using trig. Would I use sine, cosine, or tangent on this one? I would use what?
Cosine.
What one?
Cosine.
Cosine. And now that I know I'm missing an angle, what should that ultimately be?
Inverse.
It should be cosine inverse. So that's my thought process. Oh, okay, adjacent, hypotenuse, cosine. Missing an angle, I should end up with cosine inverse. And let's see if it works out that way. So we could go, you know what? We have cosine of x equals adjacent, which is 8, over our hypotenuse, which is 11. Here's kind of a shortcut that I do. We could just say I'm gonna do the cosine inverse of this side, cosine inverse of this side. What was that, Will?
Do you automatically just go into like straight multiply x sine 1 or cosine 1 times?
Remember, this isn't multiplication, this is taking of.
Yeah, I know.
Yes, I automatically do
You
that.
ended up just doing x equals sine 1 minus 15 for the one before. Can you just go straight?
We can go straight to theirs, yes. So I should know that this is x equals cosine inverse. That's why we go through that check process, because if you understand that, you can skip some of these steps. Because you don't have to show me that this cancels out.
Yeah.
We just have to have the next step that says, oh, that means I need cosine inverse of 8 over 11. In fact, when I'm checking tests, I'm making sure that you have this statement written. Or when I'm checking your work, I'm just making sure you have this statement written. I don't need this statement written. I need that x equals cosine inverse of 8 over 11 written. Let's go ahead and plug it in. Do not shout out any answers. I want everyone to plug it in their calculators. Make sure they get out the right thing. Make sure you're in the right mode. Make sure you can plug this in. A big chunk of this test is that you can actually plug this stuff in your calculator. I can't tell you how many times we take this test in geometry over my last 6 years, and I find out on the test that someone doesn't know how to use their calculator. Who could give me what about x equals? X equals about what? Yeah.
43.3.
43.3. Do we have a second on 43.3? All right. And I should probably put a degree symbol on there. All right, our next one. Sine, cosine, or tangent? Okay, cosine, sine, tangent, sine inverse, cosine inverse, tangent inverse. One person, thank you. We're going to use our tangent inverse because we'd say, okay, well, I'm going to use tangent, but because I'm missing an angle, we should use tangent inverse. So I'm going to go ahead and say, I know I need to use tangent of x equals TOA, which is opposite over hypotenuse, which should reduce down to x equals tan inverse of 20 over 37. Will, that's what you kind of talked about doing, right? Yep, just go straight to it. I'm totally cool with that, as long as you understand what's happening in the background. I'm just looking for the tan inverse of 20 over 37. Who's got it? Will?
28.4.
28.4. Can I get a second on 28.4? We're good on that? Cool. All right, last one we're doing together. Am I using sine, cosine, tangent, sine inverse, cosine inverse, or tangent inverse? I should end up having cosine inverse because there is an adjacent. I have a hypotenuse. Remember, we can run it through cosine first. We can go, you know what? Cosine of an angle equals ca means adjacent over hypotenuse. So that'd be 18 over 23. We're going to need to skip to the inverse. So I have cosine inverse of 18 over 23. Have you noticed your calculator does the heavy lifting for all these?
Yeah.
But we can't do that for special right triangles. Those have to be exact. For Pythagorean theorem, they have to be exact. So don't just get used to just plugging everything in your calculator. Do not let trig let you plug everything in to your calculator. Just trig gets plugged in your calculator, 100%. What do we get? 38.5. I heard like 4 people say that, so I'm assuming it's correct. Okay, let's do one of those famous 2 triangle ones together. I don't want to see, when I grade yours tomorrow, I don't want to see everyone left all the 2 triangle ones blank. Okay? I don't want to see that. So let's work it together. Your job is to understand that to find measure of angle W. So let's go ahead and put maybe an X right there. X degrees. I'm looking for this. I need to have 2 sides to find a missing degree. I only have one side on this triangle here. I need to use this triangle first because this triangle has an angle and a side. I have an angle and a side, so that means I can use trig. So I'm going to go ahead and I'm going to call this hypotenuse y. For this triangle right here, can we all look at the triangle, make sure we're doing the same triangle? This triangle right here, this ZYX. Am I going to use sine, cosine, tangent, sine inverse, cosine inverse, or tangent inverse to find a missing? I'm going to use basic sine. If you're missing a side, you use the basic ones. If you're missing an angle, you use the inverses. So we're going to recognize that 25 degrees has an opposite of 15. Our hypotenuse is y. So on this triangle right here, I'm going to use the fact that the sine of that angle, 25 degrees, is going to equal 15 over y. We should be able to work this out to being y equals 15 over sine of 25 degrees. Those show up quite a bit, so we should know that. What is y about? Yeah. 35.5. Can I get a second on 35.5? 35.6? I have 2 options. I have 35.5 or 35.6. Can someone give me that another digit? I have 35.5 what? 49? Can we stop talking for just a second so I can get this cleared up? Are we okay with this 35.549? Is that what your calculator spits out? Yeah. Now, remember, you look at the digit after it. So I'm looking at that 4. If that 4 is a 5, you round up. If not, you just get rid of everything afterwards. So we should just get rid of everything after, and it should be 35.5. Are we clear on that? Don't look at the 9. Just look at the 4. So sometimes that 9 will confuse you. Don't worry about that. That doesn't exist. What really only exists is the 4. And since it's not a 5, it just disappears. So we have 35.5. All right, so I can go to my drawing. I can write my 35.5 in. All right, now we're looking at triangle WZX. Am I using sine, cosine, sine, cosine, tangent, or sine inverse, cosine inverse, tangent inverse? Which one of those 6 am I going to end up using? I'm going to use tangent inverse because we do have a missing angle. But let's go through tangent first. So tangent of, what do we have? X, because we're missing that angle, equals 35.5 over 22. We're going to change that to tan inverse. And that should give me about, correct me if I'm wrong, I got 58.2 degrees. Am I good?
Yeah.
Then that would equal 58.2 degrees. So we did a double triangle in here. I should not see anyone on the homework just have a blank. All right, none of this. I'm going to leave it blank because I have nothing to do. You got to try something. You got to find a triangle that has bits of information that you can solve and go from there. At least try all the problems. All right, then we have one last thing. Word problem. A ladder leaning against a wall makes a 75-degree angle with the ground. 75-degree angle with the ground. So that's going to be kind of important. So we have a wall of some sort. We have the ground. Oh, that's pretty big. And then we have like a ladder. Perfect drawing. I guess we could draw a little. We can make it like more like a ladder. I don't know how to force perspect this. We'll say this is my ladder. Okay, let's put the information that we have. We have a ladder leaning against the wall, making a 75-degree angle with the ground. That means this is our 75 degrees. If the foot of the ladder is 6 feet from the base of the wall, so that means this distance right here is 6 feet, the bottom. From the wall to the ladder is 6 feet. What is the length of the ladder? So that would be my x there. Okay. Am I going to use sine, cosine, tangent, sine inverse, cosine inverse, or tangent inverse on this one?
Cosine.
We're going to use regular cosine because remember, it's only if you're missing an angle do you use inverses. Only if you're looking for an angle do you use inverses. And this is adjacent hypotenuse, so we should have cosine of 75 degrees equals our adjacent, which is 6 feet, over x. Our slightly tougher one, because we have to realize the x and the cosine of 75 switch places. I just need to plug in my calculator, 6 divided by cosine of 75 degrees. 23.2? Anyone else can second 23.2? 23.2, and I should probably add feet to that because that's what they're talking about. All right, questions on that? All right, let's go ahead and turn our page. This is going to be a mixed review within your group. What that means is no one should be done unless everyone in the group is done with it. You can split it apart if you want to. If you want two people doing, or one person doing 2 problems, the next person does 2 problems. I don't care how you split it up. But we need to get these done as a group. I will take a picture, not really a picture. If you guys want to pay attention real quick, I'll put the answers so you guys know if it's right or wrong. So bear with me. I'm going to read the answers to you. If you find something different, let me know, because who knows, maybe I'm wrong. All right, number 7. You should get out 13.6. 8 should be 50.5. 9 should be 17.8. 10 should be 19.5. 11 should be 6.5. 12 should be 30.6. 13 should be 12.6. 14 should be 31.8. 15 should be 14.9, so 14.9 for number 15. And the last one should be 33.1. So let's work on this as a team. If you want to break them apart, if someone's really strong, they can do a couple and help people out. If you feel a little weaker, have someone do it with you or do them all together.